Glenn Dell, world champion aerobatics pilot from South Africa and recent selection for the Red Bull Air Race World Series, is the guiding force behind the Slick 360. The professional pilot, with over 23,000 hours flying time in over 250 different types of aircraft, will be competing against 13 other top pilots in one of the toughest advanced aerobatics competitions in the world. When he's not perfecting gravity-defying maneuvers, he's flying the latest Airbus A340. He has previously flown Boeing 747 and 767s and has worked as a training captain on the 737. Partnering with some of the best local aeronautical engineers and constructors, Glenn oversaw the creation of a new champion, the Slick 360. The Slick itself is based on the Laser and Extra 230 aircraft, but is decidedly more advanced.
This is the Slick aircraft, and it's one of a series of two, the 360 and the 540. This is the Slick 540. This specific aircraft is powered by an AEI 540 engine. This particular engine is modified by Monty Barrett to produce just a little over 300 horsepower. It has cold air induction system, so the air that goes through the front of the aircraft doesn't go through the sump as with most engines. So it's cold air going directly into the cylinders, which helps to give it somewhat more power. The propeller is an MTV-9 from Gert Milbauer in Germany, and he's very well known and obviously famous for his aerobatic aircraft propellers. The spinner is constructed of Kevlar, while the propeller itself is composite material consisting mainly of wood. The Milbauer propeller, as most aerobatic pilots will be aware, is the most popular aerobatic propeller on the market, and it is the standard propeller that will be used for the Slick. The exhaust system is built by Skydynamics in America and gives this aircraft its particularly good sound. Doesn't sound at all like the normal popping four-cylinder Lycoming. The Slick itself was designed as an unlimited aerobatic aircraft. This particular aircraft has quite impressive performance and is very similar to that of the Edge 540 and in both rate of climb and roll rate. The wing of the aircraft is based loosely on a laser, but obviously with different materials used for the construction. It has a carbon fiber spar and carbon fiber rear spar, which allows it to take plus minus 10 G with an absolute strength of plus minus 20 G. Every wing that goes into these aircraft is tested in a whiffle tree prior to installation in the aircraft in order to ascertain that there's no fault within the wing that might cause it to fail. The fuselage is carbon fiber, the wings are carbon fiber entirely, whereas the Slick 360 has some glass fiber in the construction. Ailerons of the Slick 540 and 360 are both the same. They have 4 hinge points, one that connects onto the root over here, and obviously the 3 hinges that you can see along over here. The hinges are made of milled aluminium, and as you can see, it's one solid piece over there, which allows us to have a relatively small slot for the movement of the aileron, which reduces drag considerably. The trailing edge of the aileron has approximately a 7mm flat edge, which also assists in making the controls lighter. The relatively large area of the ailerons also makes the Slick 360 have a roll rate well in excess of 360 degrees. In fact, the roll rate of this aircraft, it would be very much the same as that of the Extra 300, which is quoted at 420 degrees per second. Obviously, on an aileron of this size, the balance required would be quite substantial. So what we've done is we've put a horn on the end over here, and as opposed to the 16 kilograms that would have been required in order to balance this aileron, we now only need about 1.5 kilograms in the tip over here to get this aileron to be just over 70% balanced. Okay, this aircraft is got the new canopy on it. The initial canopy was somewhat longer, probably about 5 or 6 inches longer in the front over there. And this one has been reduced in size so that we reduce the drag somewhat, and also obviously it looks good. But other than that, it operates very much the same as it always has operated before. This particular aircraft is fitted with a leather interior, which is very, very comfortable, but certainly it's just an option. And the leather interior is approximately 5 kilograms added weight to the aircraft. Inside the cockpit, we have standard instrumentation, including the radio transponder, a Mode C transponder, G-meter, an altimeter, airspeed indicator, and various engine instruments, including CHT, EGT, oil pressure, temperature, manifold pressure, fuel flow, and obviously an RPM indicator as well. We have a magneto switch, which obviously caters for both electronic ignition and the single magneto, and the aircraft is fitted out with a SkyTech lightweight starter as well as a lightweight alternator. The rudder pedals are adjustable, and a person of 6'4" can very easily fit into the aircraft with space to spare, and also wear quite a chunky parachute. In the back of the aircraft is a baggage compartment. The cockpit has a 5-point hook harness system with a ratchet, a fuel selector which allows fuel to be drained from the 2 wing tanks and the main tank. The wing tanks will allow a flight well in excess of 800 kilometers of range. Endurance-wise, the main tank, which is the aerobatic tank, will give an hour's endurance actually doing aerobatics at aerobatic power. The fuselage is constructed of carbon fiber. The only exception to that is in the cockpit area where it is Kevlar. Kevlar, as you know, is used for body armor, and so it does allow some protection for the pilot in the event of an accident. But the rest is all carbon fiber. It has 4 longerons and ribs situated throughout the fuselage for strength. Undercarriage is made of aluminium, and it's been gun drilled for the brake system, and it is made by Grove in America. Spats are of a carbon fiber and Kevlar mix. The carbon fiber to give it strength and rigidity and also lightness, while the Kevlar allows it to take any impact from stones, etc., that might be on the runway or unpaved surface. The vertical fin over here and the horizontal stabilizer, you can see it has now got a removable fairing over here, which allows the horizontal stabilizer to be removed both for inspection and for transportation. The rudder is constructed of carbon fiber with a weighted leading edge to prevent flutter. The entire aircraft has been flutter checked and no flutter found to way above the VNE of 250 miles per hour. The trim tab, which is actually electrically operated, it can immediately go to a predetermined position and obviously saves an amount of weight as well.